So this is Sustainable Westchester's Roundtable series. And today we will have our welcome, our sponsor introductions from NYSERDA, WexEnergy, and BlocPower, a keynote presentation on resource efficient electrification by Jared Rodriguez of Emergent Urban Concepts, participant introductions in breakout rooms. We're going to go with 2 breakout rooms today to make sure that everyone has the opportunity to introduce themselves and speak on topics that they're interested in. These will be curated breakout rooms. So based upon my understanding of your role in the market transition, we will be putting you into those 2 rooms with an eye on building relationships. And in those breakout rooms, we'll have our open discussion, which can include discussion on Jared's presentation on resource efficient electrification, and it can also be related to anything on commercial clean heating and cooling and building decarbonization that our participants have found interest or experience in, and then we'll wrap up. Sustainable Westchester is a consortium of member municipalities, 45 out of 46, including the county itself. And I see that we have the county on the line. Thank you, Peter McCart, for being here today. Sustainable Westchester's programs include community energy programs, Westchester Power and Community Solar, electrification solutions, energy smart homes and clean transportation project, and zero waste programs. We are building healthy, resilient communities, which improves air quality, health, and quality of living, boosts green economy and green jobs, and helps address climate change and secure a clean energy future. The Commercial Clean Heating and Cooling Program of Sustainable Westchester, I am Rachel Carpitella, I'm the program director. Was born out of the gas moratorium here in Westchester County. But since then, the Climate Leadership and Community Protection Act has been passed. So we are also supporting New York State in achieving its climate goals, 70% renewable energy by 2030 and 0 emissions by 2040. The benefits of building decarbonization include no burning of fossil fuels, a non-pipeline solution, reduced construction and other capital costs, reduced maintenance costs, save space in buildings, improve occupant comfort, improve indoor air quality, and pursue green building certifications. The Commercial Clean Heating and Cooling Roundtable is to aid in that market transformation and industry growth by building relationships, learning from other industry peers, sharing your own success stories and challenges, contributing to drafting a blueprint for best practices and resources, getting a behind the scenes look at the work of Sustainable Westchester's Commercial Clean Heating and Cooling campaign, and having an opportunity to weigh in on upcoming roundtables, webinars, and podcasts in order to inform content and usefulness. Opportunities to inform content and align resources include events led by municipalities and trade organizations, webinars and meetings with key partners, aggregating our resources, commercial case studies, podcasts and webinars, series development, consulting with municipalities in high development areas, one-on-one consultation with developers and heat pump installers, and increasing visibility of heat pumps in new construction. So if you'd like to be part of any of that, please feel free to reach out directly to me. Today's agenda, for those who have joined the event since we went through the agenda in the first minute, we have our welcome, our sponsor introductions, our keynote presentation on resource efficient electrification by Jared Rodriguez of Emergent Urban Concepts, our participant introductions and open discussion in the breakout rooms, and our conclusion. I would like to thank our sponsors, so NYSERDA, Scott Smith, if you're here, would you like to say hi to everybody?
Yeah, absolutely. And I am here. Rachel, thanks for bringing this together. And we really appreciate all the work that you're doing. Super happy to be here and see Jared speak in a while. That'll be great. Want to thank all the participants for coming and for contributing your energy and your ideas to the meeting. Thanks, everybody.
Thank you so much, Scott. And I would be remiss if I didn't say that this is the NYSERDA funded Sustainable Westchester for a overall project on commercial clean heating and cooling, and supported a series of roundtables, which we do hope to continue after this funding has been applied. And this is the last in that series. So we are so thankful to NYSERDA for getting us started on this path and for your support and guidance along the way. And we're very excited for all that we'll be able to do after this. So
Me too, Rachel. And actually, the one thing I didn't say, thank you very much to the other sponsors that decided to sponsor this event. Very much appreciated.
Yes, thank you. And WexEnergy is one of those sponsors. We have Rachel Rosen and Scott Wexler on the line.
Hi, how are you?
Scott
Walker. It's okay.
Walker, sorry.
So,
Did you guys want to give your introduction?
would you like us to do our presentation now?
Yes.
Okay, great. Hi, so I'm Rachel Rosen, CEO of WexEnergy, and I come to this from the building world. I was in property management, development, and construction for almost 30 years. And in all that time, I replaced windows only once. And that was because the expense was overwhelming and we just had to do other things. So, you know, whenever we looked at new properties, we always looked at what our options were. Doing nothing is very common, but that's not really going to help us in the world we're facing with this huge carbon problem. Sometimes we looked at window film, that's really a great solution in very hot climates and where a lot of sun is, but that's not so much of a problem in the Northeast. And we also looked at retrofits. At the time that I was in that industry, there were very few window retrofits out there that were even an option. I came to WexEnergy because I saw an opportunity for a solution that really makes a difference. So I'd like to show you what a window skin looks like. And this is a small one, comes right out of the box like this with a label on it, tells you where it belongs, and this protective film. And when you peel the film off, you'll see it is completely clear. Sometimes we even do presentations with the window skin sitting right on the camera. You don't get the glare, obviously. And people don't even realize there's a window skin. That's how clear it is. The secret sauce in the window skin is right here on the side. We engineered our perimeter so that it controls the insulation gap between your existing window and your window skin. And by controlling it, we can optimize the energy improvement for your window. So this is a low profile. We also have a high profile that's a little deeper. And when you put the window skin on, it snaps right on. We'll go like this if you were the window, right onto your window pane. It keeps your window operable. It allows you to open and close your window. We are the only retrofit that mounts on the inside of the window and allows the windows to open and close. So if you have a double hung window that goes up and down or a slider that goes side to side, as long as we can get a minimum 3/8 inch clearance between the two, the stationary and the moving parts, we can fit a window skin to your window and we can qualify the building. So window skin is really a very quick and easy installation. It takes about, on a typical window, 5 to 6 minutes in all. You don't have to relocate tenants, whether you're in a commercial office or multifamily, or even if it going into a single family home. If you have an older building built before 1975, you might have lead paint. Don't have a problem there because we're going on to the glazing. We don't disturb underlying environmental remediation issues, which can become extremely extremely expensive. And in fact, if you have old double pane windows, an old double pane clear, and you put our solar skin product on, that's a window skin that has window film added to it, you may be able to meet current energy code with that product. So you could really avoid the huge expense of window replacement and put a window skin on to solve that problem. What I often say is, if you're putting new windows in now, call us in 15 years because you're going to need window skins. Your window will have lost its energy, a lot of its energy insulation because the gas dissipates out, or put a window skin on now and you wait another 10 or 15 years. And maybe at that point, you're ready to really install brand new windows with a lot of energy doing something about the windows is because windows are a source of a huge amount of energy leakage in a building. In multifamily, it can be somewhere between 30 to 50%, depending on how tight your building is, how new your systems are, how well it's designed. So that's a lot of energy leakage, and that's obviously a lot of carbon. On the path to electrification, it's really important to look at this holistically. And as you hear from BlocPower and then from Jared, I think the whole picture will come together for you. Because if you look at what am I going to do to electrify, you can't really do a good job until you button up your building envelope, which includes the windows. And as you button up your building envelope and you reduce the leakage on the windows, now as you look to electrify, you can reduce the expense of electrification because what's spec'd for your building or your home is now going to have a lower or smaller load need. So with that, I want to say thank you for being with us. Be happy to talk to you in the breakout session, and look forward to speaking with you. We'll send out a slide deck through Sustainable Westchester that will describe and explain what we've just talked about in more detail. Thank you.
Thank you, Rachel. Next, I'd like to thank and welcome our sponsor, BlocPower. Ryan Merkin is the Vice President of Business Development.
Nice to see everyone. Thanks, Rachel, and thanks, NYSERDA. Jared, looking forward to your presentation, and Rachel, thanks for the info on WexEnergy. I agree. What we're looking to do is holistic retrofits. BlocPower role is, and our charge is really centered on decarbonization via electrification. So we're starting with evaluating buildings to look for opportunities to electrify fossil fuel using systems, heating, hot water, and even appliances too. So we can do everything, fully electrify a building. But when we go into a building, we're also looking for other things that are going to make a difference. And yes, definitely bringing down loads, looking at windows, looking for all the opportunities to enable a project, including renewables, solar, and storage, and kind of run-of-the-mill weatherization, windows and air sealing, and all kinds of non-sexy stuff that we do. So unique offering for BlocPower, for those of you who don't know us, is we provide a turnkey solution. So we could evaluate your home, building, house of worship, what have you, any building shape and size. Although getting to the very large buildings is actually one of the bigger challenges we have. And I know we're going to hear more from Jared on that. But we could evaluate it, analyze it. We do the design. We permit the projects. We do the construction. We commission the system, train folks to use it. And then for when we offer our financing, which is in the form of a lease, we perform the operations and maintenance. So we maintain these systems for, say, 15 years, and we guarantee the performance of those systems, which typically goes beyond the manufacturer's warranty, which is maybe 10 or 12 years. So we'll take on the risk of making sure those systems work for the full life of the lease by maintaining it, by also putting in connected systems so we can monitor the usage on the systems, catch things early before they break, or alert us to a maintenance issue. We could also enable residents, homeowners, and property management to be on that system too. So we're communicating about the performance of the system, but we do take on the risk for the full 15 years of a lease that we offer. So that lease can frequently be a no money down solution. So it's being paid monthly. So for those entities without the resources or capital, or like to extend a lease using BlocPower's services, we're happy to do that. And beyond buildings, we're also working, you may know us from our work with municipalities. We are running a program in the city of Ithaca, who announced they would like to decarbonize the full city of Ithaca over the next 6 years or so. That program has really just gotten underway. We had a kickoff event about a month ago. We have signed up now to work with Menlo Park in Silicon Valley, where Facebook is located. We're working with those folks too. And I think, in the coming months, you'll hear about other cities also making moves with BlocPower to administer and work with us to do construction and decarbonization. So there's a lot of work to do. There are a lot of buildings. It is construction. It can be messy. It's not going to say that it's easy, because the solutions are various. But we like what we see in terms of the technology that's coming to market, and the focus on heat pump technology. So I'll include my contact info in the chat if you want to talk a little more. But I think I'll stop there and hand it back over to Rachel or to Jared to take us away.
Thank you, Ryan. And BlocPower has used WindowSkins, right, in your applications?
Absolutely, yes. And I just had an inquiry, just thinking about that, Rachel. We have an inquiry on a historic building, and it's top of mind for me to suggest or look at whether that's a good solution for them, particularly on projects like that.
Fantastic. I would like to introduce Jared Rodriguez. Combining expertise in sustainability, urban planning, and real estate, Jared Rodriguez has extensive experience leading regulatory and advocacy programs for energy and climate-related initiatives. His firm, Emergent Urban Concepts, is a policy and sustainability consultancy that partners with business and state and municipal governments on issues related to decarbonization, sustainable technology, real estate development and management, and transportation. In addition to its work with clients, Emergent Urban Concepts advises the Empire Building Challenge, a NYSERDA program that fosters public-private partnerships with leading commercial and multifamily real estate owners to recruit best-in-class equipment manufacturers, solution providers, and other businesses to invest in low-carbon retrofit technology development here in New York State. Previously, Jared was a director at the LeFrak organization, a leading family-owned real estate company with an extensive portfolio of properties concentrated in New York, New Jersey, California, and Florida. So without further ado, I will welcome Jared Rodriguez. And stop sharing my screen.
Thanks, Rachel. All right, so let me just flip to this presentation. Everyone can see that?
Yes.
Yes, okay. So we've switched the terminology a little bit with NYSERDA, calling this resource efficient decarbonization. And what is it? It's effectively, it's a heuristic or an approach to decarbonizing large buildings. So we have a focus on large buildings in this program. And again, like Rachel said, I'm an outside advisor to NYSERDA on the Empire Building Challenge. The challenge is a $50 million program, which includes now 2 cohorts of residential developers and consulting engineers. Really, I think what we realized fairly early on is that, the big hurdle in decarbonization of buildings is it's around heat. So how do we provide heat to buildings and cut that gas connection so buildings aren't directly contributing to carbon emissions? New York State has policies in place to decarbonize the electric grid, so we need to be moving buildings over to using electricity to produce heat and cooling. So this is a sort of a funny cartoon where we've spent, I think, the last 20 years trying to ignore the elephant in the room, which is heat. There's a lot of good people that are talking about it, but in general in society, we tend to ignore it, and we want to focus on solar and controls and software and lithium-ion batteries and electric vehicles when we talk about decarbonization. And finally, we're starting to have that conversation around buildings and heat. And we're also starting to do it too because we have this problem person that we have to deal with, on the border of Europe. And so this issue of heat and natural gas, potential scarcity is coming to the fore, and we're trying to determine ways to move our buildings and industry away from gas for geopolitical issues, and then obviously also for emissions. I think it's really important to share with everyone that, you know, we've had the promise of like very cheap natural gas for quite a while. We could talk about, you know, why and how that happened, but you know, we can't necessarily rely on very cheap natural gas going forward, since it's now an international or global commodity. You know, with the fracking boom, there was an impetus to develop liquefied natural gas terminals and ship natural gas to other markets. And with Russia now being offline, providing natural gas to Europe, you know, a situation which is likely to get worse. Other markets, including, you know, Japan, even China, and predominantly the EU, are asking us for natural gas, and we will pay significantly more for natural gas, particularly in this coming winter. You know, many of you are aware of what's happening at the New York State and local level, but New York State has the Climate Leadership and Community Protection Act. You know, we're mandating grid decarbonization by 2040 and economy-wide decarbonization by 2050. That's every sector of our economy needs to hit carbon neutrality by or before 2050. New York City is pushing very aggressive emissions reduction laws, and also banning natural gas in new construction. And there's much work happening in gas transition planning, including how do we deal with leak-prone pipe? How do we not invest in the natural gas network in a way that creates stranded assets if we're moving away from gas? How do we not waste ratepayer money? How do we deal with moratoriums like in Westchester County, non-pipe alternatives? So can we reduce the peak gas consumption? And recently we've had a thermal utility law passed by the state legislature. And I can talk a little bit about that in future slides. So, you know, reaching carbon neutrality with buildings in particular is sort of riddled with myths, misinformation, misconceptions, you know, like everything, right? Like, how do you know what the truth is? It's very difficult. So, you know, some of these myths and misconceptions that have been sort of historically holding back action in this space are simple payback measures. So sort of like obsessive focus on just simple payback. So how many years is it going to take me to pay back my project, instead of thinking more strategically about it. Say another project is going to happen, right? There's a cost to the business as usual condition for building. So you have to take that cost into account when you're analyzing a retrofit project. And you also have to look at other value chains that can, you know, drive the desire to complete that retrofit project. The idea that we could just do one-to-one equipment swaps, you know, replace a big steam boiler with, say, air source heat pumps at the same capacity is generally not advisable, especially if you're looking for a project that performs well economically and you want to optimize your capital spending. So I'll talk a little bit more about that. The idea that, you know, your engineer says, no, it's not viable, well, then they sort of need to understand this heuristic. You know, we've heard from a number of, say, activists and others saying that we need to electrify everything all at once, do it as quickly as possible. It's really electrify everything, you know, efficiently and sort of eventually. Because if we tell building owners to do it all at once, they might go down the road of analyzing it, and then they will realize that is not a viable strategy to achieving decarbonization in a building. So what we're advocating for is something more like an incremental, continuous incremental approach to achieving decarb in these large buildings, and then also across, you know, urban areas and cities and large urban systems. This idea that we could just wait for better technology to come along. Well, there's a lot of enabling steps that need to be implemented ahead of time so that that new technology can be implemented. I can talk more about that as well. That this isn't a 10 priority. Well, you know, ESG goals, you know, environmental, social, and governance goals are definitely influencing publicly traded companies. So any building owner that has a publicly traded company in it, where sustainability is a focus by, say, investors, you know, those building owners are being driven to act. And then, for tenants in the residential markets, large multifamily buildings, there's more and more awareness around the social impacts of indoor air quality and air quality in general. And so that, that may be starting to have an impact on policy, as well as the desirability of buildings as well. The idea that electricity produces emissions, well, we have a law in place that will decarbonize the electric grid by or before 2040. There are massive offshore wind leases that have been signed. Work is beginning. We're building, extremely large wind ports and maintenance facilities in Brooklyn and Albany and elsewhere. We're going to turn the Hudson River into a marine highway to help support the offshore wind industry. So, you have to sort of believe that we will achieve the goal, because we have to, it's written into law. But also, I think we sort of do, and I'm not speaking for NYSERDA here exactly, but we do need a view into what that emissions profile looks like from electricity, so that building owners can capital plan or do capital planning for decarb. And that this is too disruptive, well, then you just need a decision tree. You need a plan. You need to strategically plan for this over time and not just react to fire alarms if and when your boiler fails. Have a plan for your boiler so when it fails, you know what you're going to do. So strategic decarbonization, or we could call it capital planning, it's basically long-term financial planning for building owners to manage carbon emissions. And so the place to start is really determine the term. What's the goal? In what year do you want to achieve carbon neutrality? And it can be optimistic. It could be sort of progressive and forward thinking. Even if you don't think it's viable, you still should set a goal. And then feed in the baseline starting point. So all the existing conditions, how the building is operating, and develop that discounted cash flow model of as many scenarios as possible. So, if you have limited time to do this, right, then limit the amount of scenarios that you're developing. But, you have time to do this, right, because your goal might be in 2050. Definitely value non-energy benefits. Include that with energy savings in order to justify an investment. And then it's also important to note that, near-term years require more accuracy, obviously. And then if we're looking out, it's more directional and sort of fuzzy. You can have fuzzy math if you're doing long-term planning. And then I think the idea that phase in and strategically deploying retrofits in a particular order is absolutely critical. And so here's some just high-level themes around what is sort of driving this concept of resource-efficient decarbonization. We have a grid peak today. It's generally in July on a really hot day like yesterday, when a lot of folks are using electricity to cool. And if we were to do unmitigated electrification, meaning very low efficiency electrification across the board, we would, drastically increase that grid peak and shift it into the winter. So this is not advisable because we as a society likely can't afford to build out a grid that is 3 to 5 times as large as it is today. So we need to be ensuring that efficient decarbonization and efficient electrification is occurring. The idea that this goes to the one-to-one swap, right? We have a fossil fueled heating system today. It might be steam, it might be hot water, it might be forced air. And there is a feasible or techno-economically feasible heat pump sizing that can actually yield relatively good economic returns. That might mean that you're hybridizing a building and you're keeping some of that fossil fuel equipment in place and you're displacing its use by adding heat pumps to the mix. And then just this idea that we could continue business as usual and somehow meet our goals. It's not viable. So we have to move in the direction of decarb as quickly as possible. Some of you may have seen this graph today at current emissions profiles for electricity. If we were to use resistance heat or a coefficient of performance of 1, like your toaster oven or old-fashioned electric domestic hot water heaters, we would be generating more CO2 than even a relatively efficient gas-fired appliance. So it's not advisable to be just jumping into this sort of inefficient way of electrifying. We can do better than that, and we should be driving our coefficients of performance, which are basically, it's the amount of electricity that it takes to deliver a unit of heat. We should be driving that as high as possible. And folks say that, or this is a statistic that I read recently, if we can, in general, create an average COP of 6, which might seem unattainable, but we'll talk about it, then we may not need to dramatically increase the size of our electric grid. So, we need to be figuring out ways to drive that COP up, and there are ways. So what is it? What is resource efficient decarbonization or electrification? Really, I mean, you could say whatever you'd like. We've had pushback around the word electrification because it sort of conjures some negative things. I think a lot of that comes from sort of the 70s when people were installing a lot of relatively inefficient electric heat. So we've sort of started to shift our language toward decarbonization. So, words matter. It sort of determines how we think about things and how we approach buildings. So we need to be aware of what language we're using with the general public when we're talking about, how to approach this issue. So what is it? It's an incremental methodology, and an integrated design process or approach that's combined with strategic capital planning that creates a path or multiple paths toward achieving carbon neutrality in buildings. And so where do you start? On the left side, you start by reviewing that building in depth, understanding where natural gas is being consumed in the building, exactly where, when, why, how, and what does that gas consumption profile look like exactly across various weather patterns and across the temperature spectrum that the building experiences throughout the year. And then once you know that sort of like the back of your hand, you can begin the process of targeted reductions in consumption. And so reduce really is just energy efficiency. It's high performance buildings. It's what we were talking about earlier with, window overclads and improving the thermal performance of an envelope. So we need to reduce energy consumption in buildings, particularly on the gas side, on the heat performance side, before we want to dive into the work around electrification. Or in tandem. Then go about the business of looking for waste heat. So where is heat leaving the building? This comes into the thermal performance of the envelope. Also ventilation. Are you just venting heat out of buildings? In multifamily buildings, we suck air out of bathrooms and we, blow it out the roof without any sort of heat recovery. We are just taking that air out of the building and wasting that heat and typically reintroducing cold air during the winter that needs to get heated. So there's a lot of opportunity to recover heat that's leaving the building in a variety of ways. I mean, think about the amount of heat that leaves through the sewer and enters the municipal sewer system. And then, start the process of right-sizing heat pumps in a targeted approach, that takes place over time to replace that heating capacity. And this might mean that you're keeping auxiliary heat around for some time until the technology is available, until the capital is available to go all the way and eliminate your natural gas connection. I don't know why I show this. It's a simplified version of what I just showed you, but now you're an expert on it, so I don't have to spend time on it. Here's a number of different ways to sort of review, reduce, reconfigure systems, recover heat. We know that one of the more efficient ways of moving heat around a building is through hydronic networks. So this idea that there's a thermal energy network in a building and we can capture heat where we're losing it and we could put it back into the building and move it to where we need it. Doing that in water is typically, one of the better ways to do it. And, I recognize that a lot of buildings don't have hydronic distribution. Commercial buildings, it's a little bit better. You do have a cooling tower loop that you could potentially reposition for heating. But, it's something to consider. And we have partners in Empire Building Challenge that are core drilling. They're adding hydronic loops to their buildings so that they could do that heat recovery, hybridization with heat pumps. And then, supplying heating and cooling to apartment units, for example, with fan coils. So office buildings, there's a really interesting opportunity in office buildings to recover and store rejected heat and use that to heat the building. There's a number of ways to do it. There's tons of different technologies that can be integrated together with your, MEP engineer and design engineer. But this idea that there's simultaneous heating and cooling, this is real, especially for some of our newer, very large glass office buildings. You have solar heat gain generally, all year long, even in the dead of winter. And you've got data centers, and there's lots of heat being generated in these office buildings. So capture and try to put it back in. And then in multifamily, it's sort of a different profile. So there's like an AM high hot water use, and then there's sort of like an evening high heating demand. And so where those two things overlap are both, difficulties, but also opportunities to reduce the peak electric capacity being, consumed in the building in a high electrification scenario. So I think all of that is to say that, right, we need to be thinking about design integration. We need to be thinking about heat as electric capacity in a high electrification scenario. And we should be figuring out the most efficient ways of capturing, moving, and storing that heat over time so that it can be used where and when it's needed. And so this actually is sort of an interesting graph that's showing temperature bins, right? So like 5-degree increments across the year, for example, and how often that occurs, in our area. And so, we aren't often seeing very, very cold temperatures, right? So, we shouldn't start a design project or an electrification project by focusing on that peak load, on those very cold temperatures, because I think you will find pretty quickly, especially in a large building, that trying to hit that peak load with, say, an air source heat pump is going to be exceedingly difficult for a whole variety of reasons. So it's better to start to think incrementally about it, break down the heating profile, and figure out how you can start to hybridize that building and deal with the lowest hanging fruit first. And so this is sort of a crazy graph or image, just sort of showing all the potential possibilities for this resource efficient decarbonization approach. The idea that you can sort of shift existing infrastructure in buildings to do multiple things, like using a cooling tower loop to do heating, which is viable, hybridizing systems like, tying air source heat pumps into, say, a cooling tower loop so that you can extract or reject heat in a relatively efficient way from that loop. Networked distributed heat generation, say with, window air source heat pumps. We're seeing NYCHA do this actually, and deploy a relatively efficient air source heat pump in windows and then networking those so that they can be modulated in a way so you're not peaking the building in the winter. And just the concept that we could be like more efficiently producing heat at high COP by extracting waste heat, moving it around, and then thinking about what the future looks like, where we might be entering the public right of way and sharing some of that extracted heat between multiple building typologies. So this is the thermal energy network that I mentioned earlier. So I just wanted to dwell on that a little bit. So New York State passed a law that authorizes utilities to own thermal energy networks instead of just being allowed to own natural gas. And so folks have sort of criticized utilities over time. Why are you so married to natural gas? Because the law said that that was the only thing that they could transport. Like it said the word gas. And so about 10 years ago, I and a bunch of other folks kind of realized that, and we needed to amend the public service law to allow utilities to then move into the space of thermal energy networks. So we have that law now, but that doesn't really mean anything. It doesn't compel the utility to do anything. So we sort of have to figure out a way to compel that utility to start this work and or leverage private enterprise to begin the work of developing these thermal energy networks, between buildings, in districts, at the city level, securing that waste heat and putting it into buildings. And, I see some folks from Westchester County on the phone. There is a massive opportunity to extract heat from wastewater treatment plants, which the county controls. Capture that heat, potentially store it, and get it into buildings for the production of domestic hot water and also space heat. So just to recap this decarbonization process, right? We start by assessing existing conditions, establish the goal, build the team. The team is critical. It should be diverse. It should include a lot of different verticals inside your organization. Oftentimes big real estate companies are very siloed and they don't generally speak to each other. So asset managers aren't talking to engineers. It's kind of a mess. So everyone needs to get on the same page, speak the same language, and talk to each other and align on objectives, and then adopt that resource efficient electrification or decarbonization approach. And don't be afraid to have design charrettes. And if you don't know what a charrette is, it is multiple stakeholders around a table, iterating on ideas, poking holes in ideas, throwing even crazy ideas on the table to see if something sticks. Then you can go about conducting that strategic decarbonization assessment, because you can sort of then see what the full spectrum of potential options is for a particular building or even a district. And then you can go about the business of ranking that based on economics, doing your project prioritization, capital planning for that, and then refine and iterate, because conditions always change, right? So this is not a static plan, it has to change over time. So here's a super graphic just showing what that process looks like in general. There's a back and forth between asset management or real estate and technical and engineering. This is the process that we are using with our cohort partners in Empire Building Challenge. So doing that technology baseline, what's in the building, doing the asset baseline, who's in the building and what does the building need to be to serve them, and then together developing that approach, that resource efficient decarbonization approach, strategic decarbonization planning, and then refining so that you can develop your final plan, which again is not static. So just to jump back to thermal energy networks really quick, and this is sort of like an add-on to this presentation, because all of this is new. I mean, that law just passed generally in June. Thermal energy networks are not new. So we have a system in Jamestown, New York, which is high temperature hot water. It's coming from a power plant, a cogeneration plant. It's serving every building in the central business district. That project started in 1984, and it was seeded by a grant from NYSERDA. So that's how long this goes back in the state of New York. You can think of the Con Ed system as a thermal energy network. It doesn't totally matter what heat transfer fluid you use to move heat around, but we're finding that lower temperature water is better because it's technology agnostic, meaning that you can plug in a lot of different things, a lot of different technologies. And as new technologies become available, it's highly likely that you'll be able to plug those into a lower temperature network. So again, like I said earlier, it's critically important that we drive these coefficients of performance for heat pumps up as high as humanly possible or technologically possible, so that we aren't exploding our electric grid. It's not sustainable to build out an electric grid that is 5 times or 6 times as big as it is today, because of if you think about it, the mining impacts of copper, et cetera. So it's expensive to build electric distribution. We can do other things. We've been putting pipe in the ground for quite a while. The natural gas network is being maintained with pipe that can easily be transitioned actually and used for thermal energy networks as well. So the point of networks is that you can produce heat locally from a wide variety of sources. You can make buildings sort of bi-directional, meaning that they can consume and or reject heat to that network, and share heat. And if we design these well enough, a building owner might actually have the ability to get paid for the heat that is rejecting to the network. So think about, for example, a data center which produces lots of heat 24/7. that data center might be paid to reject heat to the network. This is not unlike, say, solar, where you've got solar on your house and you are net metering your solar, and you're generally getting paid or at least credited for the excess solar that you produce and put onto the grid. So we need bi-directional grids, and also on the heat side. I think about Indian Point a lot, right? So whatever you believe about nuclear energy, but since that plant was built, right, for its entire life, we've dumped all of that excess heat into the Hudson River. Right, that's not acceptable. This was zero emissions heat that was being wasted. That's heat that could have heated quite a lot of buildings, perhaps the entire central business district, or more in Peekskill, for example. So it's not acceptable to be wasting heat in a world where we care about climate change. Just going to move on to the next slide. Okay, here we go. So how do you go about doing this? Like, how do thermal energy networks emerge? Well, the Geothermal Technology Office and the U.S. Department of Energy recently released a grant program that is meant to seed the development of thermal energy networks in communities. And they've recognized that we must form coalitions in communities, because this is complex. It involves a lot of different people. It may include the utility. It definitely includes the municipality, plus potentially private enterprise, labor, workforce development, and development of projects in general. And so those members might include, again, I mentioned government bodies, policymakers, other officials, county, local, city, state, industrial development agencies and other organizations, public and private regulated utilities. We've got a number of municipal utilities in upstate New York that could be leading this effort. Activist and community-based organizations for sure, faith-based organizations, solution providers and manufacturers, and our labor. And so some of the next steps on potentially developing thermal energy networks in communities could be, engaging with a thermal development team in a way I would call BlocPower. That they created a partnership with the city of Ithaca. They are a thermal development team. They are going to go and do customer acquisition to get folks to convert to heat pumps in order for that city to achieve its very aggressive goal of decarbonization, within a pretty short period of time. So you could imagine a company like that as a thermal development or a thermal developer. And then there's this effort to identify all your coalition members and then structure and form that coalition, create what I've been calling a thermal access agreement to allow the extraction of heat from, say, public resources, for example, and then authorize that developer, for example, to perform potentially in the public right of way. Maybe working in concert with the regulated utility. And then there's this whole effort of identifying all those thermal supply sources, creating deals between customers and heat sources, for example, figuring out ways for customers to share heat with one another in an equitable way. And then identifying and procuring your engineering and procuring and construction team to then, and maintenance and billing partners to then actually create that team that's going to build this thing. Finance and construction of thermal nodes. So like, you're not building this all at once, for example. This is also an incremental approach that could start pretty small and grow over time. And then identify and secure partners to, move these pieces of infrastructure to, say, their permanent home, which might be with the regulated utility, for example. And so I covered a lot. Happy to take lots of questions. I'll put my email in the chat. And, if at some point you want to reach out to me, then I'm absolutely happy to have follow-up conversations.
Thank you so much, Jared, for such an informative and forward-thinking presentation. To all of our members and attendees here today, Sustainable Westchester is your partner in taking these next steps So a lot of information was shared, and we are glad to help you identify how to move forward and take action and connect you with partners to do so. As Jen said, the first step is to create that team. So we're here to help you do that. We're now going to move all of the attendees into 2 breakout rooms. So bear with us while we do that sorting. In the breakout rooms, everyone will have 2 to 3 minutes to introduce themselves, share something that either a success, a challenge, a question they might have about Jared's presentation, anything related to commercial building decarbonization that you'd like to see, that you'd like to discuss during the group discussion. And after those introductions and discussion points have been brought forward, then our moderators will go through those discussion points to curate the conversation for the group. We will share Jared's presentation after this event with a follow-up email, and we do plan to have this recording available on YouTube. And we will share the resources that WexEnergy mentioned earlier, and if BlocPower has anything or NYSERDA has anything to share, we'll share those resources as well. Okay, we will start to break everyone out put everyone into the breakout room. So I'm opening the rooms, and our team is now going to sort everyone. So bear with us while we sort.
Okay, so quickly, we either come out to measure, or we can train a building manager, a super, or someone to measure in their own building. To start with, we ask to measure 1 window of each size in the building, and to get an approximately good count of those number of windows, we ask for some information on your energy cost, your usage, type of energy system, heating and cooling system you have in the building. From there, we can give you an estimate. And then when the project is ready to go forward, we come back to measure 10 to 15% of each window size. So if you have 500 windows in a building, we're measuring around 50 to 60 of those windows. In some buildings, we can even get away with 20 or 30 measurements. In other buildings, maybe we would need more. Depends on the building.
Okay, thank you so much. So now we're going to go through, and everyone can give a 1 to 2 minute introduction, your name, who you work with, and any questions, topics for discussion. We can start with Peter McCart, and I will put the list in the chat, if we can go in the order that I'll put in the chat for introductions. And Jess is going to capture the questions and topics for conversation. Thank you.
Thank you, Rachel. I'm Peter McCart. I'm Director of Energy Conservation and Sustainability for Westchester County. I work at the behest of the county executive. I work in the county executive's office, kind of like a cabinet member. So we are vastly working on, just all the components of, what we talk about every day: electrification of our building, adding renewable energy. We work on renewable energy workforce, working with full clarity, full transparency. I also sit as board of director on the Sustainable Westchester, so I have a good relationship with Rachel and all the whole gang there, and all the good work they do.
I didn't want to, cut anyone off, but I think we do have to head back to our main room. Let's continue these conversations. We'll have future roundtables. Thank you all so much.
Thank you, Rachel.
Thank you. We'll be back in the main room.
Thank you.
What robust discussion in our breakout rooms. This is absolutely fantastic to have such a strong network of like-minded individuals working toward a common goal of building and community decarbonization. Thank you to our keynote speaker, Jared Rodriguez, for his brilliant presentation on resource-efficient decarbonization. Again, I'm Rachel Carpitella with Sustainable Westchester, and I welcome all of our participants today to reach out to me with any questions, comments, or if you'd like to take next steps toward decarbonizing your municipality, your building, your school. And I'd like to thank our sponsors, without whom we could not do this work, their generosity: NYSERDA, WexEnergy and BlocPower, thank you each so much for supporting this work. Your partnership is invaluable. Until next time, take care.